So good morning once again. Today, the 30th of January, the date is wrongly written there. We are starting with our online lessons, and what we are looking at today is science paper 1, which is physics, and the topic is electricity. Just to give you a preamble, electricity is one of very useful components in our day-to-day lives, because for you to make it to this class, you are using electricity. You might have charged your phone perhaps yesterday night, or maybe yesterday in the evening, or maybe you are charging it even now. You're using a desktop. You are using a desktop, definitely you must be connected to electricity. So it is very important that you and me get to understand one or two things pertaining to electricity. So first of all, this electricity, there's nothing new about it, because we also learned it in grade 9 integrated science. It may just be one or two things that have been added. Now, from the grade 9 introduction of electricity, perhaps we may get to know one or two things. However, this electricity we are learning today is split in two parts. So we have that electricity that flows in wires like the one we are using today, to charge phones, to watch TV, to do one or two things. There is also another electricity which does not move. We need to know that. So, what is this other component of electricity that does not move, which maybe we are hearing for the very first time? This form of electricity is called static electricity. What is something static? It's something that is immobile, something which is not moving. So when you just hear of the word static, the only thing that should come to your mind is something that is immobile. So first of all, what is electricity? Electricity is defined as the rate of flow. So we're talking about something moving, the rate of flow of electric charges. So wherever there is electricity, we must be rest assured that there must be some mobility of charges somewhere. Now, what are these charges that we usually focus on under electricity? The charges that we talk about are electrons. From the introduction to chemistry, we understand very well that is among the subatomic particles that we have in atoms are electrons, and these electrons have particular charges. That's why we're saying they are charged particles. However, because today we're talking about static electricity, the electricity which does not move, therefore it must be stored somewhere. Where is this energy? Where are these charges stored? They are stored in objects. They are stored in objects. So we are saying, remember again, I'll be referring a little bit to chemistry, where we were told that a neutral atom is an atom which is not charged. Neutral as it may be, the number of positive charges and the number of negative charges are equal. That's why it is neutral. So meaning objects with neutral objects, we are saying they have protons which are positively charged that are also equal to negatively charged chemical species. So all neutral objects that are not charged, they contain these static charges. Speaking of a pencil, speaking of a pen, speaking of a paper, shoes, anything neutral we are rest assured that that is a source of static charges. They don't move. But something which is as small as charges that we cannot see with our eyes, they don't even move. How are we going to know that they exist? Or how are we going to experience them? So look at look at look at clothes. June, July, when it's very cold, we usually put on jerseys and things like that. In the night, lights out, then you're trying to remove the jersey. You will at times experience, you will at times be experiencing some kind of electric shock, some ticking sound within the hair as soon as you rub your jersey against your hair. That experience, we even see some white stuff around, more or less like malite or anything like that. So Mukuka, you cannot do the recording because I'm saying the recording is already done. That is an insight of static charges that are kept within the hair, also kept within the jersey. Now, when they are rubbed against each other, these static charges are excited in one way or the other. The excitement of these charges, we'll look at them as time goes by. So we are saying here that when two objects are charged, when two objects are rubbed against each other, we are saying how can we charge these objects that are neutral? So first of all, we have this object with positive charges and negative charges that are equal. For it to be charged, one of the two charges must be dominating over the other. If we get to have more of positive charges within this object, we are going to say it is positively charged. If we get to have more of negative charges within the object, we will say it is negatively charged. So we are trying to move from a point where positive and negative charges are equal to a point where a particular charge dominates. Okay. So how can we charge a neutral object? Simple explanation is when these two objects are rubbed against each other. One object will have more of particular charges and the other object will have more of the other type of charges. And by so doing, we're saying that those two objects will be charged, but differently. So this point here is just trying to talk more about what I've said, what neutral atoms are, neutral objects, and things like that. Now, let's see, how can we get to witness that indeed this object has been charged or the other object has not been charged? Right now, where you are, I want you to get a pencil. You get a pencil or a pen, perhaps. You rub it against your hair. If you have got impala mbumbute, too good for you. Rub against your hair 3, 4, 5 times. Rip off a very small piece of paper from the tip of the book and then bring that pen close to that small piece of paper. You will find that that small piece of paper will be picked by a pen or by a pencil. The reason is as you rub your pen or your pencil against your hair, you are charging that pen. And when it is charged, should you bring it closer to a pencil you'll find that that paper will be picked up. I'm giving you a minute, just do that. You confirm with me. Yes, guys. So have you done the simple assignment that I gave you? Have you confirmed? Yes. Okay, one more important note that you have to take. The learning we are having today, we'll never learn it again. The presentation I'm making today on this particular topic, I will never teach it in class. That's why I'm a bit slow. Like I said, this link will be shared, notes will also be shared. That means whatever you guys will be learning today must be written in your books, because this is a continuation of where we ended. So yes, Towela, thank you very much. And Helen, be reminded that you have to write in your book, your physics book, because this thing is a continuation of where we ended. Thank you so much. So if you have done what I told you to do, that's even better. You rub your pencil pen against your hair. Try pick a small piece of paper. You'll find that that paper will be picked. The reason is when you rub that pen against your hair, that pen is getting charged. And when it is charged, it means it can pick another object that has possessed different charges. So continuing from where we ended, I've told you how we can charge an object. Now, even when it is charged, we are just saying it is charged. How are we going to know the type of charges that that object will possess? How are we going to know the type of the charges it will possess? But maybe let me have a further illustration on how the rubbing gets to charge the other object. So these two objects were electrically neutral from the beginning, meaning the number of positive charges in a cotton wool as well as the negative charges were equal. Same applies with the polythene rod that we have here. Now, by rubbing here, by rubbing, that friction form that we experience when two rough objects are rubbed against, it will cause a transfer of the electrons from one object to the other in the form that they have indicated. Now, because in the cotton wool, the number of positive charges and the negative charges were equal, and when these electrons move, so we are saying at the end of the day, we are going to have more of positive charges on the cotton wool, and we'll have more of negative charges on the polythene. But in a moment, you bring a positively charged species. In a moment you bring, let me draw this one here. In a moment you bring a positively charged species against a neutral object. What are we likely to find? We are going to experience rearrangement of charges. We will have more of negative charges shifting this side. We will have more of negative charges shifting this side. But this was just an insight. More of the explanation will be given on the next page. We are saying that these charges are being transferred from one point to the other. How are we going to know that this object here has a positive charge, this negative here has negative charges? How are we going to know? Therefore, there must be an instrument that is used to detect the type of charges possessed by an object, as well as the number of charges. There must be an object that is used, an instrument that is used to detect the type of charges possessed by an object, as well as the number of charges that it has. So which instrument is that? Which instrument is that? That instrument is called the electrostat. So the electrostat is the instrument that we use to detect the charges that are possessed by an object. So this is what an electroscope, this is what it looks like. So the instrument that is used to detect the charges possessed by an object which is charged is called the electroscope. So when you rub your pen against your hair, the ability that it has to pick a paper, we can detect the charges that it possesses. Now let's look at the features that an electroscope has. The first feature is that it has got a brass disc. This disc here is metallic. Brass, you haven't maybe learned brass. Brass is an alloy. It's an alloy, combination of two or more elements that are physically joined. Then we have an insulator here, a plug. This plug here is an insulator. It's an insulator, and I'll give you the reason why we need an insulator here. After that, down here, the casing is a glass bottle, not a metallic. These are a few things you need to take note of. The casing around the electroscope is made of an insulator, which is a glass, just like this insulator here that we have. Down here, we have a brass rod. So this thing goes all the way up to down here. On top, it's just a disc, but it's made of brass, a good conductor. That rod that we have there is also a good conductor. It's made of brass as well. Then down here, we have a gold leaf. Have a gold leaf. Then we have a metal foil that is connected to the point where an earth wire is connected. Now the question may be, why do we need to have the casing, which is an insulator? This insulating casing is there to provide a discontinued flow of charges. In case there are charges that are possessed by the golden leaf, the brass rod, these charges should not escape through the earth wire, because we have an insulating casing here, which is a glass. Secondly, why do we need a gold leaf? A gold leaf, they are different, of course. Gold leaves are different. Yeah, they're different. But basically what happens is this. This gold leaf is going to tell us, it's going to detect how many charges are possessed by the rod that we brought near it. The gold leaf, I will explain in the details. Yes, so I'm just trying to introduce you to each and every part that is here and its function. The other reason as to why the casing should be made of glass, so that it becomes easy for you to see the type of charges that are there. Remember, we are seeing the type as well as the amount. So to provide a best visual perspective, we need a casing which is made of glass. Of course, as science is advancing, we have digital ones where the type of charge is displayed there, but we are talking about an analog way, which is an odd way. So what really happens? What really happens? What really happens? Let me show you. In a moment, you bring a positively charged rod. Let's start maybe with a negative charge. We have our negative charge, the rod brought near it. Not in contact, but just near it. These charge, remember the brass disc is a neutral object, meaning the number of positive charges and the number of negative charges are equal because it is neutral. So now when you bring in close, when you bring a negatively charged rod close to it, what's going to happen? It's that moment in life when you are going to sleep, you remember you need the water from the kitchen, you turn on the lights, you see how fast cockroaches go to hide with their brown jackets. That's what really happens here. All the negative charges that are in this, disc will run away because we have brought in other negative charges. So what really happens to do with charges is that the charges that are the same, they cannot be next to each other. they must be pushed away. And this is what we call repulsion. I'll explain it later. And the charges that are different, if one is positive, the other one is negative, just by nature of them being different, they attract to each other. And this is what we call fundamental first law of electrostatic, which will be explained in the next slide. So when this negatively charged rod was brought near, all the negative charges that were on this disc were pushed down through the brass rod. They ran away from their fellow negative charges, leaving only positive charges around this environment, so that there will be a stronger force of attraction between these different charges. And remember in chemistry, when we're looking at bonding, ionic bonding to be specific, we said ionic compounds are the strongest compounds because they are strongly held by intermolecular forces and electrostatic forces, and these forces as a result of positive charges as well as negative charges. That's how these ionic compounds are strongly held together. So this is the same thing that happens even here. The moment negative charges are brought near, all the negative charges will run away, and this is what we call repel. They will repel. It's called repulsion. And when two different charges are brought near, what happens? They will attract to each